Charity, the show's yours.
Certainly. Well, welcome everyone, and thank you for joining us. In this 1 hour session, we're going to try to share with you guys some of the work that we did. We are a team of faculty from Florida Tech, and there were 3 other schools who worked with us, and they're present here. So hello everyone. I'll briefly introduce to you guys the ones who will be presenting here. Before we do that, Bree, are you presenting the slides that Denver created, or how do you want to go about that?
I have slides for my tool, and I can talk a little bit about Michael's as well.
Perfect. We'll pass on the baton to you at the time. And the Lawrence Tech team is here. I see Chris from George Fox. So there are Lawrence Tech, Denver, and George Fox. Those are the 3 universities who partnered with us on a grant funded by the foundation. The grant's title is on the top of the screen right now. Let me quickly move some of the stuff here. Yeah, so the objective of this grant was to understand the state of making as it is being used to propagate the entrepreneurial mindset throughout the schools in the network. And then based on that understanding, propose or create some reusable tools that would ultimately be published as keen cards that other members of the network would be able to use, reuse, adapt, adopt in whichever way they want to onto their respective campuses, so that they could use making experiences as part of coursework and otherwise to propagate the entrepreneurial mindset within their communities. So that was the main goal, and what we came up with these 6 tools that are currently on the screen. We originally wanted to do a workshop within the Keen National Conference next year in February, and for valid reasons, our request was not honored. It was declined, and instead we were asked to host one of these sessions. So this is just a 1 hour time slot, and we have to be judicious about time here because we have 6 tools to share. So the 6 tools that were created, they were created 2 each by Denver, George Fox, and Lawrence Tech. And we will give you a very quick overview of these slides or these 6 tools, and then from there we'll pass it on to the actual developers who can talk about these tools in a little more detail. Okay, so the first up, let me see if I can advance the slides here. There's a tool called Making in the Classroom. It was developed by Drs. Roselle, Caston, and Gordon at University of Denver. So Bree, if you want to take it over, let me allow well, I think you can share your own screen if you want to.
Oh, thank you.
Yeah, kick me out. I think yes.
There we go.
Sorry, I had to.
No, you're fine. From the beginning here. Introduction. So yes, our first tool that I'm going to be discussing is called Making in the Classroom. And ours is a little bit different because, and I apologize too, I have a cold, so I sound a little strange. It's not COVID, I've tested many times. But the tool that we have is actually a faculty development tool. And so the goal of this is to help anyone who's teaching a course to figure out where is a place I could put making into that course, and how could I make sure that that making project is entrepreneurial minded. And so the course outline that you would go through if you're a faculty going through this course is, or an instructor of any kind, what is making, examples of where you could add making, how do you include the EML, and then of course looking at assessment and evaluation, both evaluation as far as, how did the project go? Did your students learn? And then a self-evaluation of, what would I change next time? This is just the example of the card that's published module 1. And so looking at module 1, this one, for example, is what is making. So you would watch two different, it's one video split into two parts just for size, but you'd watch a video, and then there's also copies of the PowerPoints. And then with each of these, there's also worksheets and handouts. So it's meant to basically be an asynchronous short course that you would go through in order to develop your own tools. So what these kind of look like, so these are different videos. They all just are narrated PowerPoint slides where I talk about, fortunately not with a cold, the things that are relevant for each of those sections, give some examples of what has happened. And then once you've gone through and watched the videos, there's different worksheets that can help faculty guide their way through thinking about this on their own. So for example, in this module 1, which is what is making, there is a worksheet on making resources. And this is something that, you know, we can continuously add to and edit, but it gives the faculty or instructors ideas on, you know, what type of making tools might be available that aren't the ones that are on your campus. So things like free CAD softwares, or if you're trying to teach about 3D printing, or you can, you know, go look up great videos that go over additive manufacturing. And then along with this, we have what we call our brainstorming worksheets. And this allows the faculty to, after they've watched the videos, they've thought about it, they can actually start to get their thoughts on paper. So for what is making, one of the first worksheets, this idea of making resources. And it's, you know, a lot of us may know that our campus has a makerspace, or maybe there's a makerspace in our specific departments, but we don't necessarily know what else is going on around campus, around these areas. And so being able to really reach out and look for those. Also thinking about things with software. I know here at DU, we just became an Adobe campus, which means that I now have access to a lot more types of software I'm really excited about. So that's a whole new area that I can add into my making resources. The big piece, integrating EML. So there's a whole section or module for this short course that discusses EML specifically. I do recommend anyone who isn't familiar with EML, they go and watch Doug's wonderful videos, the 101 and the 102. But beyond that, I talk a lot about, you know, how making inherently matches with EML, which is well is the answer. So there's a lot of the 3 C's that go along with making. And then again, we've set up these worksheets so that you can go through and really identify, you know, what pieces of this project do I want to focus on EML, or what pieces of EML am I going to bring into this project? So it's kind of a chicken or an egg. You can kind of pick which direction you want to think about it. And hopefully at the end, the goal is that our faculty should have an activity that they can try out and that they can iterate on. And so, oh, half my pictures aren't showing up, but we have had a lot of different fun examples of making projects with our students. And, you know, I think the thing to consider is that a lot of times we think making can only be in, for example, a design course where of course you're making something. But our goal is to try to spread this out to lots of different courses. So things like fluid mechanics or circuits or thermodynamics, where maybe you're not seeing those as obviously. So that is that one. Any questions?
I just have a comment that Anthony, my colleague Anthony, is here, and he is our makerspace guru, and I actually am thinking about incorporating this project into my biology class, so not just fluid dynamics but even other STEM classes. So
Awesome.
I actually had a math professor was trying to they were looking at 3D printing some different like shapes for calculus of several variables. He wanted to show like different geometries and stuff. So lots of different ones.
That's awesome. That's really awesome.
Have you
Brianne?
are you aware of any, I'm sorry, Susan, my own colleague, I cut her off. Are you aware of any individuals that have applied this to like a humanities-based course? Because we were thinking about doing a campus-wide lunch and learn using some of your activities in this card.
Michael, who unfortunately had a conflict and couldn't be here, I know he's worked with anthropology in the makerspace. So let me check in with him and let you guys know, because I think that they have done some things.
Awesome.
At least half of the students in Michael's card were non-engineering.
Oh, wow. Okay.
And yes, there have been some cards published, both with regard to humanities and with regard to biology. In fact, one of the things that I've had to do as part of the grant is organize all of the cards as best I could into card decks. And after the meeting is over, I will gladly help people with regard to finding which card deck is most relevant to what they want. But I'd rather have us move on at this point.
Certainly.
Thank you.
Thank you. In the interest of time, let's move on. I'm just going to share the master deck of slides one more time, so that we know that this is a, will be more than happy to share this deck of slides, which has the basic information about all the 6 tools. And at the bottom of each slide, there is a link that takes you to the respective cards. So we can share this. So the next tool that is coming up is also from, hold on, there you go, from Denver. So Bree, over to you again.
Actually, we can keep, if you want, you can keep that slide up.
Absolutely.
To share.
Give me a moment there, right there.
Nope, you're fine. Yeah, so this was, as I said, Michael Caston worked mostly on this tool. I said, unfortunately, he couldn't be here today, but his is kind of the example of what happens when you take a tool and then put it into a classroom. And so his is the objectives were, learning about additive manufacturing, also CAD, depending on what the student's background was, and then applying the design process to a community partner. So really his was focused on the reason that it's called engineering for the public good. We here at DU, we are a private university for the public good. And so the idea is bringing in community partners so that students have that really good connection, right? One of our EMLCs to the community and to having a real world type project. And this could be, as you just mentioned, this doesn't necessarily have to be for engineering students. Michael runs a living and learning community on entrepreneurship that we do have several STEM students in that course, but he also has students from all over campus because it's open to all first years. And so this idea is taking something as technical as CAD and additive manufacturing, but adding that more humanities side, that public good side, to show them what the design process looks like, even if they aren't engineering students. And so this, excuse me, so this card goes through like a real world project, shows cool things like personality tests and other things that the students can look at that maybe we don't normally do from more of the STEM side, and develop. And he worked with Garrett and Shannon, and neither of them were engineers. But Shannon, I think, is a PhD student, and Garrett was a geography major who was really interested in making. And so he worked with some students on this project that was really fun. So that is our other card.
If I may add, seeing as I was the LTU member who tested this tool, and I have some experience actually running exactly this project, I found it valuable enough. I'm running it again, right? So I'm running it in one of my courses as we speak. It's very, very good, I think, at getting students focused on impact, right? On understanding the value creation aspect of entrepreneurship, in addition to trying to see their engineering skills in the real world, right? It's very good at getting them sort of out of the classroom mindset, I found.
And one of John's students was coming down and asking me about ideas for what community or what local community would be a good example for that type of activity. So.
Yeah, John, I was going to actually follow up and ask you briefly, how challenging did you find it connecting with resources outside of the university, so those community partners?
So I was able to advise my students on some very simple inroads that they could make. So I had some students actually contact our library. So the tool itself, I think, gives a helpfully broad understanding of what a community partner is and who a representative of that community partner would be. And that could be anybody from, making something for the library versus, going to, a local community center, like a rec center type thing. Trying to find sorry, to go back to your actual question about like, how do you find good places to send your students? I find that students already have places, right? I'm trying to get the students to think about where are they in their daily life and to really consider themselves as, in the different spaces that need them, that need their skills to solve problems. So I try to get the students to think about where they are already, where do they already spend their time, and try to look around themselves to find partners.
Yeah, I think that's really great, and the reason I asked is just to kind of address that. One of the biggest fears of maybe trying to implement this card for a faculty member would be, how do I get that project? How do I get those community partners? And the fact is, that it could be, the campus could be the community, and like you say, the students are aware of these things. And as a last resort, you could always, give that, make up a partner if you had to. But I think I like your approach, John, let the students go wild and find a partner that's in their area of interest too. Thank you.
So I should have probably made it more clear that, as I mentioned, the three universities, George Fox and Denver and Lawrence Tech, worked with us. So we'll be switching back and forth between the different slide decks. Keep in mind that although we are hosting it, the work was done mainly by our partners, and there were universities who took the responsibilities of developing the cards, and others pitched in to test them. So like John mentioned from Lawrence Tech, that his team was part of took the responsibility of testing out the engineering for the public good card that came out of Denver. So there are cross-pollination everywhere. The teams that developed the cards were not primarily in charge of testing them. So at the time of publishing the cards, the tools were tested at least, by two different community members within the four schools of us. So the next three slides are going to be presented by the team from Lawrence Tech, Susan Henson, Heidi Morano, and John Paponis. And those three slides are here. Again, for some reason, there we go. So I can drive the slides, John and Heidi and Susan.
I think that works for us.
Okay.
If you just go forward. Yeah.
Right, go.
Yeah. So you can just go to the next slide. So I'll start with my tool. I kept my slide very minimalist. That 3D scanning is a little too big. It's covering up the thing. That's fine. My tool was about trying to teach students about entrepreneurship and making in the context of making customized designs. So I think a really good way of getting students to understand how their skills can be used to fill a need in a market is by thinking of different ways that they can make customized products. So products that are tailored to some individual in a way that sort of mass production isn't. And I think that's one of the strengths of the different making tools that we talk about, especially 3D printing. And in order to enhance the ability of students to think about that in terms of 3D printing, I focused my card on 3D scanning. So I made this tool very user-friendly, as in it should not take you thousands of dollars to buy a very high-tech scanner. We used Xbox Connect 360 scanners actually, because the sensor from the Xbox 360 Connect is very cheap and you can find them used. We've recommended it for others to use as well. And we use a free software called Skinect. We actually bought a license for the more high-powered version of Skinect. A fun tip: if you buy one license, you can then have all of your students use the same license. Quick tip. But we showed students first how to use a 3D scanner. So part of the instructor guide that was published with the card information was all about how to take a scanner, a sensor, use the software to produce a model of some body part. So the one that we talk about in the card is a custom orthotic, where students would scan one of their partner's feet and then custom fit a design to the bottom of that foot, and then try to actually print that. You could for the purposes of the card, the module that you would integrate into the classroom, you would be merely designing it, because then the second part of this module for an engineering classroom, I should have mentioned that this module is specifically designed for your typical first year engineering course, engineering projects course. And then the next part of the project is to then take this new skill that you have developed by using a 3D scanner to develop a customized product for someone in your own life. So a friend, some member of your family, etc. And try to make a product that is not just, going to be fulfilling some need, but is also customized, right? It is going to fulfill a need specifically for them, because you will be able to use a scanner to get the specific geometry that would help you solve their problem, not just a general problem. So the general learning outcomes of this are mostly about trying to get them to not just engage their sort of curiosity about new tools for engineering. So 3D scanning is not something that we tend to see very many first year engineering students having much experience with. Meanwhile, many high schools now even have 3D printers. But also trying to, once again, hit home on what I think is one of the biggest needs out there, which is to introduce especially freshman engineering students to understanding the impact that they can have with their designs, right? I can make something that will change a person in my life's life. That was a strange sentence. Today, I can design something for them today that will change their life tomorrow. And there's not, a long lead time. It's not going to take forever. I can see the results of my work right away and in the life of someone that I know, right? I think that's all I had to say about this. Once again, you can find the card. We can even post that in the chat, as I saw people posting before. We can take questions, or we can go to Heidi and Susan before we take questions, maybe as a
Let's
group.
take some questions at this
Okay.
point.
Before we take questions, Chirdeep, can you just share the card page?
I'll get the cards posted in a second here.
I got John's card.
Heidi, you said you got John's card?
I will post that one.
All right. Thank you.
It's 2325, Chirdeep.
Okay.
Any questions?
Yes, I do. I do have a comment. I implemented this semester after the this part of the grant was officially over, and the Microsoft's Connect was very useful in my class. I do appreciate what you did quite a lot. One of the biggest concerns I had going into this project was that you can spend a lot of money on a 3D scanner, or for that matter, I used to do that same sort of thing with 3D printers and laser cutters. And the Connect is cheap enough that you can have several of them. And one of the things that I found in trying to implement a lot of these technologies is that it's better to have more cheap devices than to have one really expensive one.
I totally agree. Okay, if there's no questions, I think we can
Sure. All
move
right.
on to
Okay,
Heidi's.
yeah, let's move.
So the next one is also from Lawrence Tech. So take it away, guys.
That'll be me, Charity.
Sure.
My tool revolves around something called a scavenger hunt. I'm sure most of us are familiar with this hunt, so to speak. This tool has been incorporated into our engineering freshman class, Fundamentals of Engineering Design Projects. we also use it as an icebreaker. The scavenger hunt starts out where students are given or select from some means the name of a tool that's found on campus. They are placed on random teams, and as a team, they go ahead throughout the campus to try to find these tools. The map shows the location of our maker spaces. These include our build lab or our wood shop and our fab lab or our machine shop. The students then are tasked with coming up with information about that tool that they selected from that random draw. They have to find out if they can use the tool or if a technician has to use the tool for them. They find out the hours of the lab itself, and then they do some research on what the tool does. They have to show evidence that they've actually gone and looked at this tool by taking a picture of them and one of the lab techs, and then using some format like a Word document or a Google document, they write up all this information, and that information gets shared with the rest of the class. Now, as all the members of the class have the same information, we ask the students to create what we call a tool catalog. And this tool catalog now has very important information that the students can take with them throughout their journey at Lawrence Tech. In order for the students to become better acquainted with the tool, we've incorporated something called the Can Crusher. And I'd like to just share with you that the Can Crusher portion of this tool was really generated by Rob Fletcher here at Lawrence Tech. He created this tool based on a need when he was in industry. How do you handle the amount of cans that are accumulated in industry and try to make their presence smaller? So it's a fun thing to create. It's divided up into 3 parts. A dispenser where the cans are placed and then dispense into the crusher itself. And then once the cans are crushed into, they go into a transporter that transports these crushed cans into a bag. But we made some modifications to Rob's initial can crusher design by making the students use the tool that they researched in the building of the can crusher. Bree Roselle at the University of Denver, she was our partner who tested our tool, but only a portion of that could be really enacted just from the standpoint that COVID interrupted our semesters. What she did is she incorporated a fully remote scavenger hunt for those students who could not come to campus. And she augmented the building piece or the can crusher. She switched it out to something called a social distance trick or treat device, where students had to find objects and develop one custom 3D print that a student worker had that would print out for her groups. We feel that the hunt really allows our students to become better acclimated with the various maker tools on campus. And as a result, they build a little bit more confidence of where to go. Mm-hmm. And then the ability to better understand the tools and what they can be used for helps them become, understand what tool creates what value based on the need of the project at hand. So that's all I have to share with you. Are there any questions?
I wanted to add a comment. So I'm currently teaching the freshman class, and we've used both of these tools in my section of 24 students this semester to great success. I wanted to make note that John's card also has a all remote version of this tool that can be used as well. This was a godsend when we shut down last fall, or I'm sorry, spring, I was actually able to do the scanning tool with finding body parts, which sounds morbid, but a file of body parts from Thingiverse. So we had the models of the scanned parts that we were able to then utilize for the customization in their project. So for the can crusher and the tool catalog, we just had our students research the tool and find an image of the tool online and basically find the relevant information there. And then one last note before I give it over to questions. My sophomore studio course has to utilize the fabrication spaces a year later in their program. And I had a student this semester that said, hey, can you use wood with this tool in the Fab Lab? And I go, would you please look that up in your tool catalog that you generated last year? And he did go back to his tool catalog. So again, the purpose of the tool was clearly met there. Thank you.
And to say, as was mentioned, we used this, or I tested this tool last year, and then I used it again this year with a much more normal format. Some students could be a little less social distance, and most of my students were in person, and they absolutely love it. They have so much fun. My mechanical engineering lab managers all love it because they get to meet all of the students as well. So I think not only knowing where the tools are and the spaces are, but just having them meet the people that are running those, so that when they had questions, they knew who to go to, was awesome. So I would highly recommend a version of this for everyone.
Yeah. At Florida Tech, we have had Scavenger Hunt sessions before, and students absolutely love it. I mean, that it gives them an excuse to get out and in an informal setting, learn about the campus and how they can use these resources. And they're going to basically live and breathe this campus for the next 4 years if you apply this to the freshman class. And it really makes an impact. It opens up their horizons about what is possible and what is available to them. So thank you. Any questions from the audience?
Yeah, very quick question. Is there any reason for applying these tools with the freshmen particularly?
In terms of the scanner or the scavenger hunt?
I mean, in general, like the 6 tools here, I mean, the focus I see like in the freshman years. Is there any particular reasons for doing this?
From our perspective, the tools that John and I have shared with you are incorporated in our freshman class. They are, for certain projects, they form teams, and they do have to use tools. So we start them off using the engineering design process, working on projects, and off they go.
I also do believe that a lot of the tools that we're discussing in general, not just the LTA ones, have some specific applicability in mindset building and also skill building that will then serve the students well as they go forward in their careers on campus. However, I don't think that any of them necessarily have to be in the freshman setting, but I think that a lot of these are very good at illustrating foundational concepts and building foundational skills.
The 3D scanning one, I think, is much better for somebody who's already had CAD.
Mm.
There is such a dependency in some cases. For example, you could say that the scavenger hunt tool is probably best applicable to freshmen, because by the time students are sophomores and juniors, they have figured out the campus. And in fact, if they were not exposed to those resources through this type of a tool, then they would still figure it out, but it makes the most impact if delivered directly to the freshman class. But for many other of these tools, and two more are yet to come, it could be argued that some of this could be applied, like the engineering for public good. It's such a mindset-oriented tool that it should be reinforced, if possible, at multiple levels, because freshmen look at engineering and life differently from or in comparison to how seniors or juniors look at it. and their perspective changes. And this whole idea of why is engineering a means to improve life for the public, that changes with it's an enormous amount of maturity that the students go through. So you could argue either way, I believe, for many of these tools.
And might I add that some of the reasoning behind ours was purely selfish on my part, because I taught the sophomore level course and I would find such a wide variety of skill set coming into my sophomore course that this kind of brought everybody up to the same level, or at least exposed them to something that they hadn't been familiar with coming in. So it's you can see a difference. So.
I just have a more general question to kind of throw out to the group. We're kind of reevaluating what we're doing in our engineering design graphics course. And do any of you have, other than these great slides you put together, a book that you're using to walk through the design process, or is it mostly kind of your own notes and PowerPoints?
It's my own notes and PowerPoints, but I've actually put together an entire card deck on that I'll share in chat fairly shortly.
So there are engineering design texts that you could use, or I'm sure that you're familiar with those, but besides, like Orica Eppinger sort of design texts that teach you the design method and the iterative nature of the different phases and things like that. Besides, are you talking about those or something?
Well, I think a lot of those design texts go a little too deep for us. I'm in a community college where I have students in my course that are their freshmen for their engineering degree. And then I also have some manufacturing folks where this is a capstone course that's finishing out their certification. And so a lot of the textbooks that we've seen just go above and beyond where we want to go with these students, and to have them buy such an expensive book when we're using so little of it just doesn't make a lot of sense.
Right.
At Fox, what we've used kind of as our foundation is the human-centered design work that comes out of IDEO with Stanford. I haven't used their actual text. I think they have their field guide to human-centered design, but we'll just pull a lot of their kind of workshops as our foundation.
Okay, and yeah, that's one of the websites I know I've been browsing recently as well, as we're kind of looking at how to redesign some of our content.
I've liked their stuff. It feels a little less technical. Like it feels like it can be a little broader, but still has the substance in it.
Now I realize it was a really long link. Put one in the link. It's the Landis book. It's called like Studying Engineering. And one of our other faculty uses that one they do like a 1 credit first year course where they go through more the basics of like that, but it does talk about the engineering design process. And I actually use that graphic in my slides. So I kind of go off of that other book that they use, but I don't use the book specifically. But I think they think it's similar. It's like a less technical version.
Okay. Yeah, I think I actually took his workshop out at California, the first year experience.
As like world-class engineer, I think that's what he calls it too. Anyway, I've done it as well, but yeah, it's a good book.
Well, thanks for sharing that, Bree. Well,
Could I ask one more question?
yeah, absolutely. Yeah.
I wanted to talk a little bit about the tool catalog. I have not implemented that tool here, but one of the things that I found when I visited George Fox University was how well their makerspace was organized, and their maker coordinator told me that by labeling everything in their makerspace as to where it goes, it saved him considerable time telling students where to find things and where to put them back. I probably waste 5 minutes out of a 2-hour lab class period just looking for tools that students have moved from one point to another. How common is that?
As someone who is informally running many engineering labs, it wastes a lot of time. One of the reasons the tool catalog is so useful, right, is because LTU does not have a centralized makerspace, right? A lot of the tools that we have are distributed across campus, as you can see from the little map. It's that is one of the reasons why the tool catalog serves such an important purpose, because it is part of organizing it for a student, a reference guide to the distributed nature of the tools that they could use and the resources on campus.
I've even found, I haven't used this exactly, but I think I might want to look into this for this coming spring with one of my manufacturing classes. But even with our Maker Hub being centralized and everything, they're constantly, it feels like, at least adding new stuff. And so doing something like this, for me, it's sophomores that are doing this. But where I still send them over there, and this will be nice because I've kind of just ad hoc something to go make them go find what options they have. But having something to go, even if it's an established Maker Hub, and see what all their options are, and to actually intentionalize looking at all those, because there's things like we have a vacuum former that I honestly had no idea that we had until a student came back and told me. I was like, oh, we added one of those. That's fun. But so something like this is great, even if it's more established in terms of a maker space.
Thanks, Chris.
All right, so let's move on. There are two more tools. So Chris, would you be taking over now? So there are two tools that were developed at George Fox. The first one is a fluid mechanics related tool called Generate Good Times Command, and it was developed by Ben Giudice. And Chris, are you presenting this, or
do you want me to?
Did you test it, Jay?
I did test this.
I might let you present it because you probably know a little bit more about it than I do, because I was on the other one.
Good. Okay. Ben from George Fox University developed this for his fluid mechanics class. So going to Khaled's question from earlier, we did pick some projects that were very much freshman oriented, but the last two tools that we're going to be looking at have more of an upper class or multi-class flavor to them. One of the concerns that I had when we were starting to pick tools in the first place was that there were a fair number of people that were doing things at the freshman level, and a lot of people who were doing it at the senior level, but not many at the sophomore and junior level. And that was one of the things that I liked most about the partner schools that we picked as part of this process, was that they were better at implementing things in the sophomore and junior curriculum. And this is an example of that. Before getting to this point in their curriculum, the students at George Fox University have already learned 3D printing and laser cutting as part of their freshman second semester curriculum. And this is to further that experience. And basically what they are asked to do is adapt to what is listed as a quote unquote standard faucet. Well, one of the challenges that I had in implementing this is that we're not at home, and lab faucets are generally quite different from quote unquote standard faucets. And so I had to, when I was doing this, I was supposed to test the remote option rather than the standard option. For the standard option for this tool, students were supposed to design their own system to show how you could take water and harvest electricity from that. And so that was the general guideline behind the tool, and how you implemented that was largely up to you. But what you see here is the prototypical example for that particular case study. And you can see that there are some 3D printed parts. There's a little flywheel there. The tough part was the adapter. And then from that flywheel, you've got to have some sort of energy conversion device to convert that mechanical energy into electrical energy. And so one of the goals for this was for students to demonstrate an understanding of all aspects of energy conversion and to be able to write that in terms of things like the Bernoulli equation and reinforce what the students were supposed to learn in the lecture class. I would, if it were up to me, I think that this probably would be better implemented in a fluid mechanics lab. If you do have such a lab, this would be a great activity for it. If you've got to incorporate it into the lecture, it certainly can be done. It's about 2 weeks of the course curriculum that's part of that. And certainly the students will get some value out of that. It says that it was best done in teams of 3 to 4. And that was how it was tested by the official testers of it. As the or the remote tester, I actually was tasked to have students demonstrate this on an individual basis with minimal instruction. And so what we decided to do was make this our proof that you know how to use the 3D printers and the laser cutters activity, in addition to proving that they know how to use CAD. And for a little while, that was a bit of a challenge with regard to the faucet adapter, but that really wasn't Ben's fault. That was more the fault that in the labs that we have on campus, we didn't have a quote unquote standard faucet. And so that required a little bit of retooling. But after a fair amount of testing, we did get this to work fairly well. And now it is a standard part of my making class for students to prove that they have CAD, laser cutting, and 3D printing skills. Questions?
Questions from the audience? Right. All right. So anyways, we are coming close to the hour. We have one more tool to go through. So the last slide on my deck here is the last slide, last but not the least, Arduino Makathon, developed by Chris Sharp and his team at George Fox. So Chris, over to you. Do you have your own slides that you want to share?
No, this will be great.
Good. Okay. No worries. Go on.
Yeah, so this was developed by myself and Chad Stillinger here at Fox. Basically what it is it's a pared down version that we tried to make more portable, both across disciplines, ideally, and across years within one's academic journey. So with our class, we have a full semester maker project that introduces an Arduino. It's the second semester, first year course. So it's for all engineers, or at least all being our electrical, our civil, and our mechanical. And so for it, we'll give them a task, design something that helps the elderly or helps young parents or helps kids or for kids. And then they spend all semester learning the Maker Hub, learning coding, learning microcontroller via an Arduino. And we use the Arduino platform primarily as our base. So what this card talks about is a pared down version of that. So it could be introduced either in the summer as kind of like a Makathon, a maker's competition. It's over, so theoretically this could be done in a week if you really wanted to pare it down. We didn't do it by weeks or anything. It's over the course of 4 meetings, where your first meeting is kind of get to know, some general background. Second meeting, you get some iteration, some review on your initial designs. Third meeting is you're deep into prototyping, and then your fourth meeting is your actual competition. we'll do like a gallery walk and a presentation and along those lines. The key distinction that this does bring in is it introduces the Arduino, not the Arduino, that's just our name. The Arduino specifically using this Arduino projects book. It's something we've found as a great kind of introduction to programming. It's our first, the way we first introduced programming and first introduced them to Arduino in general as a microcontroller platform for prototyping and whatnot. And we found it really kind of builds a great base. So all the information is there, as well as kind of a base for what could be done in the meetings, and then it could be scaled accordingly. This was tested by Michael at University of Denver. And it was kind of fascinating to get his feedback. He had to modify it a little bit, I think, for some of the content. But the course that he used this with was across disciplines. So it wasn't just engineers who are taking it. And from what we heard, he said it worked out pretty well, but I'd definitely love to hear more insight or thoughts as people try it out, or definitely be willing to answer questions about more specifics regarding it.
All right, thank you.
So.
So we have some time to have a few questions and a general discussion.
What was that Arduino book that you used again?
It's the Arduino projects book. It's what it's called. It's kind of, and you can get it with a base kit. So it comes with kind of the base tools that you need. So that's what we've started going towards. It costs about, I think $75 per kit. So we bake that into their class fees for our course where we practice it. But it makes it very useful in terms of they have the base electronics that are involved, as well as it walks them through the initial coding for getting some basic circuitry set up. So what we use in our class is we'll use this for the homeworks, for the practice, and then this gives them the foundation to go and do their own thing to piece the things together.
Okay, thanks.
Does each individual student get a kit? That's what you're describing.
Yeah, we'll usually split it up. So for our class, we have teams of 4. So it's 1 kit per team of 4.
I see. And how many students total in the class?
Generally in the class, we've got 3 sections, about 20 some per section.
Okay.
So about 60 students, 60 to 80. It's been varying the last couple of years.
Mm-hmm.
With the $250 kit, and I have students use that instead of a textbook, you can get a very complete kit, not just including Arduino stuff, but also the sorts of sensors and controls that you'd like them to learn as well. And
yeah,
they have about $50 in there for a project for the end of semester. And one of the things that Chad Stillinger, Chris's partner, has done very nicely is boil that down to about $100 for just what's absolutely necessary.
Especially for like an intro version. So this is really more designed for kind of an introduction to coding, introduction to programming. We do use this as our text. Well, not actually as our text, but we don't have them buy a text for the course. We've been developing slides, our own kind of ad hoc textbook. So this is in lieu of buying a textbook. Their fees cover this.
I'd like to, since we're starting to get a little bit low on time, circle back to the question earlier about why maybe a lot of these were geared towards freshmen. And I think what you'll find with these 6 tools is they really span the full 4 years of the engineering education. We have the introductory tools like the Scavenger Hunt that can get freshman students acclimated to campus, comfortable getting around campus, getting to the maker spaces, introducing themselves to the lab techs. And then like with the fluids, the generate good times, come on, that really most, at least in our program, fluids is a junior level course. And at that point, if the students have come in as freshmen and they've learned where all the maker spaces are and where the tools are and how to use them, you would imagine as sophomores, depending on what the track they're taking, they could implement any number of these other tools. And then as juniors, they should all be competent in running 3D printers and laser cutters and being able to build the tool there. So I think, if we're kind of approaching this as a really way to integrate making fully into the curriculum, there are plenty of other ways to do it for sure, but the 6 tools that we've developed are a good start as well.
Certainly. So we are fast approaching the end of the hour here. Thank you all for coming. I was actually probably noticed I was trying to grab screenshots of all the attendees so that we could send out the content. But then I realized that first, some of them are still showing us James Brenner. And second, Jennifer is still here. So I think, Jennifer, if you can join the call back and give us a little, would you be able to?
Did the second
share
link
the
I
content?
send work?
Say what?
Did the second link that I sent with regard to downloading slides actually work?
Yeah, the slides, the link you sent us for the these slides that were used in the presentation did work, the second one.
Okay, good, thanks.
So they were already shared. Thanks. Other than that, if you guys have any further questions, feel free to reach out to us, and we will make sure that this content is further disseminated through the foundation in the upcoming newsletters and other sharing avenues. But to you guys, I realize that the cards have just been shared by Jim. Other than that, if you have any further questions, please feel free to reach back to us.
And I assume the video is going to be made available.
Jennifer?
The recording.
Yeah. Yes, we will just edit out the pre and post stuff, and we'll get that shared out on engineeringunleashed.com. There's a page dedicated to the live discussion recordings, and that'll be in the newsletter as well.
Thank you.
Yeah, I'll post a link to it on the Florida Tech site, and I'll send an email to that once that becomes active. Once I've gotten access to the recorded file, the MP4.
All right.
All right.
Thank you all for coming.
Thank you all for coming, sharing, and joining us.
Thanks for hosting.
Yes, thank you very much for hosting.
Absolutely. Thanks for organizing, Jennifer.
Absolutely.
Nice meeting.
All right. Well, it was great to see you all.
I hadn't met before.
Yeah, it was.
Nice to see you, Jennifer. Thank you.
Good to see you.
For hosting us. This was great.
It's a good start.
Yeah, I'm excited to get some meatier conversations into these, and so this is a great start. So thank you so much for sharing all of this. These are great tools, and we'll get all of the information together. So I'll be in contact with you once we get everything going.
Awesome.
And
thank you.
And I can also get you a report of who attended. I might be able to get email addresses associated with the attendees, even if their name said James Brenner. I'll see.
I've got the emails.
Sounds good.
All right. Yeah.
All
Take
right.
care, everybody. Bye.
Have a wonderful day. Bye-bye.
You too, Jen. Bye.
Bye now.